All right, everyone. Welcome to a session of GoLab 2020. I'm the talk manager. I'll be managing the talks and Q&A session. So we're just about to watch the recorded video by Sina Siadat called All About Interface Values, Common Patterns and Type Analysis for the Empty Interface in Go. I'm going to bring Sina live just for a moment so that we can have him here while I introduce his bio. So, oh, Sina, I can't bring you live. All right, well, I'll just read the bio and then we'll have him here for the ending part of the Q&A. So he'll be here live at the end. So all about Sina. He is a former Ruby programmer, Go programmer since 2013, open source lover, has several minor contributions to Go, Tmux Ruby on Rails, etc. He fell in love with CSP in 2007 in his final year at university. He loves learning new and old languages. He is learning French and Latin, as well as Scheme, OCaml, Rust. He plays the guitar and makes music, and he has 2 long rods in his body supporting his spine, and they trigger metal detectors in airports. So about this talk, it will be he'll be talking about what type would you set for a variable that can be either an int or a float 64. He'll present several patterns for addressing this problem using interface values, as well as a tool for analyzing the set of all possible underlying types of an empty interface value based on Alan Donovan's work. He'll look at examples of real code where these common patterns are used, like the Go standard library and protocol buffers, to help you decide where to incorporate them in your own projects. So just a quick reminder, if you have questions to ask, I would like to direct you to the buttons underneath the chat headline. So next to the room chat, you'll see a question mark icon. So please ask your questions there, and we'll have Sina answer those live at the end. So enjoy the video and stay tuned. Thanks.
Buongiorno a tutti. My name is Sina Siadat. I'm a freelance Go programmer. That's my Twitter and GitHub usernames. The title of this talk is Intertype, type analysis or type checking for annotated empty interfaces. So let's take a look at the agenda for this talk. This presentation is about interfaces in Go. So in the first part, I will talk about interface types and what we can do with them. And in the second part, I will demo Intertype, which is a type checker or type analyzer, or whatever you want to call it, for annotated empty interfaces. So it's a way to impose some kind of constraint on the dynamic type of empty interfaces. So basically what we will do is we annotate an empty interface with some type constraints and run intertype before compiling the code to check if we have violated those constraints. So in the second part, we will go through examples and see how Intertype could help us work with empty interfaces. So let's start the first part of the talk, types. Programmers coming from dynamic languages to a typed language sometimes feel like they're working for the compiler as opposed to the compiler working for them. They feel that types take away their freedom so that the compiler could compile the code. But types, in the sense that I am talking about, is for humans. Compilers don't need this kind of type. They could manipulate bits however they like and continue to run. Maybe compilers use type information to do optimizations, but in this presentation, I'm not concerned about those optimizations at all. I'm only concerned or interested in types and type checkers as tools for humans to write correct code. So you could think of types as rules that we set for our system. If x is declared as an int, it should always remain an int. Or you could think of them as promises that we make. We promise to use x as an int and nothing else. Or you could think of them as tests, and type checkers run those tests. We expect or want x to be treated as an int, and the type checker will check that for us. But I like to think of types as constraints, because we want to reduce the possible states that a variable and hence our whole system could have. The smaller the set of possible states a system could have, the simpler that system is. So, as counterintuitive as it might sound, constraints are good, and we want constraints. So, let's now talk about types in Go. I'd like to think that Go has 3 kinds of types. The first one is concrete types, like int, float, bytes, buffer, empty struct, not empty struct, a channel of integers, a func that receives no argument and returns a string. Concrete types are very strict and simple. They are black and white. For example, you can only use an int as an int, and that's it. There's not much else to say, or I don't have much else to say about them. Moving on to the second level of abstraction or kind of type, interface types. These types, in my opinion, act like containers. They hold the concrete type inside them and expose a subset of the methods of their dynamic value to the outside world. So interface types themselves are static types. That's important to note. But the value inside them has a dynamic. The type of the value inside them is dynamic. So interfaces. Let's see how we use them. Interfaces are used by calling one of their methods, or making an assertion about them, or using reflect and unsafe package to inspect their dynamic contents. So that's it, the second level of abstraction. Let's now move on to the third level of abstraction. But before that, I'd like to note that a lot of people like to categorize Go's types into 2 levels of abstractions, concrete types and interface types. But for the sake of this presentation, I'd like to add a third one. And this level of abstraction, in my opinion, is the empty interface type. I put the empty interface type in its own level of abstraction as a joke, firstly, but secondly, because it is not. It is a different beast with different use cases. So of course there is only one type in this category, the empty interface itself, which is an interface with empty method set. But when and why is this type used? We use it when we cannot express a type using Go's concrete or non-empty interface types. it's like a fallback, and we use it for everything else. It's mostly used by authors of libraries to allow their users to pass in variables of a set of types that, again, is not expressible using the other types in Go. So, what are the use cases of the empty interface? The first kind of use case is some functions are able to handle multiple types. For instance, the printf function is able to print many types that do not implement a single interface. And I think that printf is able to, in fact, print every type in Go, I think. The JSON.onMarshal is also able to handle many types as long as they are pointers to something. So these functions accept an empty interface as their argument. So this is the first kind of use case. The second kind of use case is sometimes the function doesn't care at all about the values that we pass to it. For example, context with value is able to receive a value and store it somewhere and return it at a later stage, but it doesn't care about what the type of the value that we give it. So it also uses empty interfaces. But please do not use the empty interface unless you really have to, because Go's compiler performs no type checking on the dynamic values inside an empty interface. You will be missing a lot of features and a lot of benefits that the Go compiler and type checker could provide if you use the empty interface. So the empty interface imposes no constraints on the type of values that you can assign to it. You might intend to assign only a limited set of types like ints and floats, or like functions, only functions, but you don't know the signature of the function. So your intention might be to limit the set of possible types that you assign to an empty interface. But if you make a mistake in your code and assign something like a true or a slice or a float that you didn't intend, then the compiler will not complain. One problem that a lot of Go programmers, some Go programmers try to solve using the empty interface is to represent a sum type. A sum type is, for example, when you want to store values of two distinct types that don't share a method, so you cannot represent them using non-empty interfaces. So you want to represent such a type, you should probably use the tagged interface method instead of the empty interface method, empty interface approach. So the tagged interface approach is to force two types to share one method so that they could be represented as an interface, a non-empty interface. So I will now explain how I build sum types in Go, and a lot of other people do that. If you want to take away only one thing from this presentation, I think it should be this. So if you want to store values of type Go and JS in one variable, we define our types like that. The empty struct is just, I just will it could have been anything else. So we have our types Go and type JS, and we add a method to both of them. So we tag both of them with a method called isLanguage. This isLanguage method acts like a tag. It doesn't do anything. The function body is empty. So now we have two types that both implement the isLanguage method. And now we declare a language interface or lang interface that has a isLanguage method in it. So both our types implement this new interface. And now we can represent a some type of Go or JS using the lang interface. Now, now Go type checker will help us if we make a mistake. Here we have a variable called lang of type lang, and we are assigning a string to it, which is incorrect. And the compiler will produce an error for us because the built-in type string does not have a method called isLanguage. Okay. So this method is pretty good, and the standard library uses it, and the protobuf package in Go uses it for implementing the one-of fields in protobuf, protocol buffers. But it has a few minor issues. One is that it's a bit verbose. We need to write not a lot of boilerplate code, but some boilerplate code, which is okay. The second one is that our values could also be nil. So we have three possible types. Is a better way to rephrase it. And the third minor issue is that there is no exhaustive pattern matching or type switch for this this implementation of some types. For example, if we have a type switch here and we are handling JS type, case JS, and we are missing the case Go, the compiler will not produce any errors. This can be problematic when we refactor our code and we add a new type that implements the language or interface, for instance, Python, and but the compiler will not produce any errors that we have forgotten to handle Python cases in our type switches. So, as I said, in the standard library, this method is used. Here, the expert node is the tagged method that forces those types to have a common method and a common method, and therefore all implement the expert interface. So it's a pretty good solution. But that was a solution for a common use case of empty interfaces, a common misuse case of empty interfaces. So if you want to represent a sum type, use the tagged method. If they don't share a method, force them to have a shared method using tagged methods. So, but still, standard library uses the empty interface for some functions. Sort.slice.json.unmarshal template funcmap. By the way, these functions will probably be re-implemented using generics when generics are out, but some of them will still use the empty interface. I think the last one will still use the empty interface. So the standard library uses empty interfaces, but it has good reasons to use the empty interface. The reasons or the advantages it has is that first, it is written and designed by the Go team itself, which is important because they have great, perfect knowledge of the language, and there are analyzers for popular functions like I listed in the last slide, for functions that receive an empty interface in the standard library. For example, there is an analysis pass in GoPlease for sort.slice, which parses our code, finds all invocations of sort.slice, and checks if the value we are passing to sort.slice is in fact a slice of whatever type. Same is true for JSON.onMarshall. There is an analyzer in GoPlease that looks at all invocations of JSON.onMarshall and makes sure that we are passing a pointer to whatever, to that function. So, but what about code that is not inside the standard library? Like, for example, YAML.onMarshall, which is a popular package for working with YAML files. It receives an empty interface. It has the API of YAML.onMarshall is identical to JSON.onMarshall. It has two arguments. One, the input bytes, and the other is an interface which is supposed to be a pointer to something that the package will fill with values that it has parsed from the YAML file, YAML input. So we could write a checker for YAML.onMarshall and for our own use cases of the empty interface. But then we will have to write an analysis for each function and each type like GoPlease does. But all we want is that some given interface's dynamic value should be a function or a slice or something. Wouldn't it be nice if we could check our code by writing only one line of code? Well, this is exactly what we will do using Intertype, which is a proof of concept, a prototype, something I've put together to demo now. So I will start the second part of the presentation, second part of the demo part of the presentation now. Okay, let me just put this down here. Let's switch tabs. Okay, so this is a normal Go program that I'm going to overview what type errors look like to warm up. So let's say we have a variable type int, and we pass in some string to it. I don't know why, but we do it. And we use that I so that we don't get unused errors. And we run that code, and we get a type error. Cannot use string type untyped string as type int in assignment. Okay, line 5. Okay, so what do we do now? Okay, so but if we declare this as an empty interface, then we are free to do anything we want. 1.5 string, everything. And then we run our code. And there should be no errors because empty interfaces could contain values of any type. So, but what if we intend to only store ints and floats? An int and float do not share a common method, so we cannot use the interface. We could use the tag interface solution as I described, but I'm going to demo Intertype, so I'm going to use Intertype. So in Intertype, I declare a type, let's call it number, and it's an interface. It's an empty interface, but it has some annotations in it. When I say in the title of the video is annotated interfaces, that's what I mean by annotation. Intertype, this is a special comment, and then I say one of int and float 64. So I have an interface. Let me type my variable as number. Now, if I run intertype demo, then intertype will give me an error, which is great. It says that on line 12, number cannot contain dynamic type string. Allowed types are int and float 64. So let's go fix that on line 12. Oh, line what? Line 11 here, sorry. Line 11, we comment this out, then we run intertype, and the error goes away. Great. So this command line thing is cool, and we could use it in our makefile or in our pipeline somewhere in CI or whenever before the tests are run. But wouldn't it be nice if I could see the errors here when I'm writing the code? Well, I have forked GoPlease and included Intertype in my fork of GoPlease to run Intertype as one of its passes. So if I run my vim and GoPlease is initialized, now if I uncomment this line, I get a Intertype error here. It's a warning. It says that Intertype warning, number cannot contain dynamic type string. Allowed types int float 64, as I mentioned here. So to fix that, I could either comment this out and the error should go away, which it does, or I could add string here as a number for some reason, and the error will go away. Okay, so this is the one-off. Let me just. This is using the one-off feature of Intertype. Now I'm going to show you. Now Intertype does one thing else for us. If we have a type switch, it will make sure that we are handling all the types. So I create a type switch here, and I handle, for example, int and float 64 and string and nil, and the error should go away as it does. So if I forget to add the string case, forget to handle the string case, Intertype will show me an error. It says a missing type string, or you could miss float 64 as well, missing types float 64 string. So if, for instance, if you refactor your code and you add you remove string and you add float 32, then your code will compile with no errors. But if you run Intertype, it will tell you that you need to fix these two errors, because string is no longer a valid number value. I've removed it and replaced it with float 32. And here I have a error as well, which says that impossible type string and missing type floats 32. That's impossible. Okay, remove string and replace it with float 32, and the error goes away. So that's exhaustive type switching in using Intertype. Okay, now what is next? The next is another feature of Intertype. Let's say I want an empty interface to contain only functions with any signature. So they could return and return as many arguments or with any type, and receive as many arguments as they want. So I say is func true, and I create. Let's do something else here. Let's work and say we have a function work that receives a func, which is which is just an empty interface, but an annotated empty interface for Intertype. So this function, I should only be able to pass functions to work. When I make a mistake and pass a number to it, Intertype will tell me that expected a function got float 32. So let's give it a function, an anonymous function, and the error will go away. I could show his slice as well. So now this thing is, let's name things properly. Now this thing should be a slice, and Intertype is telling me that expected a slice got a func. So let's give it a slice, int, a slice of int, slice of bool. All of these are okay. Next is chan. So I should give it a channel int, error goes away, channel bool, no errors. And another interesting one, let's call it work, and let's say fields. We want a struct that has a field, a name of type string. Okay, and now here Intertype has given us an error, which I don't know why it disappeared. Here I'm getting the error, but my editor is not showing it, so let's reload again. Okay, want a struct with fields.name, but we're giving it something entitled channel. So let's give it a struct of type field with that field. Let's define that struct. Let's define that struct to be, I don't know, something like my struct, and then struct, and then I say that it has a field called name string, and then I create my struct here, and great, the error goes away. But if I change the name to, I don't know, not name, then the error comes back, and it's saying missing fields dot name string of type string. Okay. This is the full name of this my struct. Okay, so and that's for that. Next, I need to show you something cool. So this was great for the types that we have redefined in our code. But what if we want to annotate a type outside our package? For example, what if we want to annotate YAML.unmarshal or sort.slice like GoPlease does? So let's move to the second demo, and let's open my demo here. So I am using comp.equal as an example. This function, let's look at this signature. This function receives two empty interface values, and it expects that these two interface values should be of the same type, or we want to make sure that we pass in the same type, values of the same type to this function. So here we have an error that might happen, and as you see, there is no warning, no errors, and this code will compile fine like Go compile. So what we do is we annotate it in this file. So this annotation has two parts. One is the matcher, what I call the matcher. It says that the equal function in this package, you should run this check on it, which is saying that parameter 0 and parameter 1 should have the same types. All right, so let's go back and save the file and go back to the Go file. And here we have Intertype showing us a warning. Expected same types got int, which is not equal to string. And if I make them equal, the error goes away. Awesome. So I'm going to just uncomment the rest of them because I'm running out of time. So I need to run Go imports to import these packages, sort, and so let's run them. Cool. So let's, for the sake of being pretty. Okay, so I need error messages here as well, and for these functions. So I use Intertype annotations here. So there is only 2 lines of annotations for each function. For sort.slice, I'm saying that it should be is a slice. For JSON.unmarshal, I'm saying is pointer, what the second parameter. For sort.slice is sorted. First parameter should be a slice. For sort.slice stable, these are all in the standard library, and I don't think that GoPlease has any analysis checkers for these functions. And the reason I think is that they are not very as popular as sort.slice. But it's since it's just 2 lines, why not add them here? And this one is the coolest one, because a analyzer for this is not ever going to be in GoPlease, because this is not in the standard library and not everyone uses this package to work with YAML files. But I've added a checker for it here very easily. I'm saying that the second parameter should be a pointer, just like JSON.unmarshal. Okay, so I reload my file and I get lots of errors because I'm giving them wrong types, just to show you that Intertype has produced the errors for us. Okay, I think that's it for the demo. And I'm going to end my presentation. To recap, interfaces. Empty interfaces are used to represent types that we cannot represent using other types. But the problem was that Go compiler and type checker do not perform any type checking on the dynamic type of the empty interfaces. The static types are type checked. The solution implemented by the Go team is GoPlease, which is to write analyzers for the most used functions in the standard library. The solution I have prototyped and demoed is to allow every programmer to annotate their own types, their own functions and functions in their dependencies. The advantage of Intertype is that it is concise, just a couple of lines. It is reusable. You can use it for your own functions and your dependencies, and has lots of features, and it can grow. Have a look at the repository, github.com/siadat/intertype. And I'd like to thank, I'd like to emphasize that this is just a proof of concept. The annotation format will most likely change. And feel free to comment on it. Just let me know. And we could include it in the Intertype, hopefully. So thanks to the Go team for creating a great language and awesome standard library and tools like GoPlease. And thanks people at GoLab and Develer for giving me the opportunity to talk about a topic that I love. And thanks for my family for their love. I should also mention my father, who passed away last week while I was working on my presentation. He was a skilled engineer and a loving and supportive person. He was an inspiration for me and a lot of people who knew him. So that's it from me. Thank you very much.
All right, everyone, we are ready to go live with Sina. So welcome back. Seems, oh, there, look at that, you're playing. Fantastic. Well, yeah, welcome back. And just as everyone is saying in chat, we are so sorry for your loss. It's always hard to lose someone so influential in our lives.
Thank you very much.
Yeah, definitely. Before we go to the actual questions, because always we have a lot of them, was there anything you would like to add about your participation in GoLab for this year?
It's been a really interesting experience for me, and because it's my first experience talking at a conference, and it's a special experience because it's online. I tried to make it like a normal presentation, but yeah, it was fun, and I learned a lot while I was preparing for this presentation. In fact, I built this tool that I demoed just while I was preparing this talk. So it was a really good experience for me.
Awesome. Glad to hear that. Yeah, a lot of times the best way to get to know some kind of concept better is to teach it. So yeah, you definitely get to learn more. Fantastic. All right. Well, I think we have quite a few questions, and I do want to just re-ask a few that were probably already answered in chat, just to see if you had anything to add. Okay. Is that okay?
Yes, sure.
All right. So the first one is from Frederick. He says, for me, this topic is theoretical and very interesting, but I didn't have this problem yet. When does it occur? If I have to deal with a variable, which can be a float or an int, I decide which makes more sense for me and handle it when the variable enters my application. Or is this more of a lib developer problem?
It's more of a lib developer problem, yes. And the int or float example was just the simplest example I could come up with to explain the concept. So yes, Frederick is right that we don't really need to, we don't really have this exact use case that we have to choose between int or float 62. I mean, one might have this problem, but not very often. But this was just to show that there could be two types that don't share the same method. So we could use something like in the tool that I demoed to check their dynamic values. Yep.
Okay, sounds good. Let's see. Next question also answered, but in case you have anything to add, Brecht says, are the checks performed at compile time or runtime?
Yes, they're before compiling. You could run the check like a linter, as someone commented.
Like you said, sure. Thank you. Another question from Frederick is, if you can change the caller and callee code, I would always go for the interface solution regarding ensuring a field of a type in the arg. I guess that wasn't a question, but is there anything you'd like to add to that?
Can you read that again? I didn't understand.
Yes, I'll link it in the chat as well. He says, if you can change the caller and callee code, I would always go for the interface solution regarding ensuring a field of a type in the arg.
An interface, I think he means or she means an interface with methods. Yes, that's right. That's exactly what we should do. We should define an interface with methods. So the compiler type checker will check that we are using we are passing it types of values of correct types.
All right, thank you. Another question from Valerie. How far can you go with annotation predicates? Is it possible to combine them? And are there plans to introduce more predicates and ways to combine them?
I'd like to emphasize that this is just an idea that I wanted to put out there. It's just it's a proof of concept, and yes, it will if people start to use it at all, then yes, it could evolve and more checks could be added, or the annotation syntax could change. But maybe no one will use it, or maybe people will use it just for the use cases that I described. So I just wanted to present the idea and put it out there that there is this kind of check that we could do on our empty interfaces as well. But we should really, really avoid the empty interface if we can. But if we have to use the empty interface, then this tool is there to help you.
Sure, that makes sense. Yeah, we have we have answered a few questions from that from your response, because Valerie also asks if you have plans to improve on the current state, and if yes, by how much.
It depends on if there is any if anyone starts to use it, then we will see what happens.
Okay, and I guess also maybe this was answered as well, but I'll ask it just in case people are wondering. We also have a question: is there a plan for IDE integration, Golang, or VS Code?
So what I showed was a fork of GoPs that includes Intertype. So I could push that. I haven't pushed it on GitHub, but I could push that on GitHub and So Go Please, what all the editors can use Go Please. Go Please is really great. Go Please is a language server that is able, and that all the editors are supporting. Go Please exposes a protocol that all important text editors like VS Code, Vim, Emacs, they are supporting. So if I push that Go Please fork, which is just a few lines I need to change on Go Please, then you will be able to use it in whatever editor you have. So I have to take a note to push that.
Great. Thank you for that. Yeah, and he says, thank you. I didn't notice the Go Please integration. All right. Well, I think... Oh, okay. So we do have another question just in general chat. Elon says, if I want to see the Go Please fork so I can use it, is it in your repo?
I will push it and provide a link in the main repo in a few hours, right after this talk.
Okay, great. Thank you for that. Well, let's see. I don't see any other questions that haven't been answered yet. Let's see. All right. So in that case, is there anything else you wanted to add? Oh, we see. And thanks for your TMUX contribution.
Thanks. Thank you very much for allowing me to talk about this topic. And I think I'll need to, I said it several times, but I need to say it again, that you should really avoid the empty interface. I'm not going to, I don't want to encourage new Go programmers or any Go programmers to use the empty interface. They should use the other types. And this talk is just meant for the special cases, that rarely happen, that we need to use the empty interface. And that's about it, yeah.
All right. Well, thanks for that re-emphasis. Let's see. Frederick also says, I would be very interested in a talk about TMUX, Vim, and Go. Maybe he's not alone?
TMUX and Vim. All right. Cool. I didn't understand last time you said TMUX. Okay.
Yeah, it might be something for a future talk.
Okay.
Awesome. All right. Well, I think that might be just about it. So I just want to say, Sina, thank you for coming here, for your contributions. And we're very happy to have you, even if this edition of GoLab is virtual. Hopefully we'll see you again next year too.
Thank you very much. Great pleasure.
My pleasure. Yeah, thank you so much. All right. Well, hope you can enjoy the rest of the conference.
Sure.
Thank you.
Thanks.
All right. So that's about it for our talk. If you want to rate if you want to rate this talk, you can definitely do that on the agenda page of GoLab, and we'll be waiting for you for our next talk that is happening at 20 past the hour, so 1:20 p.m. Italian time, which is building domain-specific contexts using DSLs in Golang, and that's by Piyush Verma, so we'll hope to see you in that next one. Thanks, everyone, for your great questions, your great participation, and see you in the next talk. Thanks. Goodbye.